What is up, everybody? Today I'm going to be talking about disk scheduling. Before we can go into disk scheduling, we better learn about the basic stuff like disk and all that. We're going to be talking about secondary storage structure. Oh, that's so clumsy. Alright, so let's talk about what actually it is. So suppose uh, I have some sort of like axle here, which we call spindle. Let us assume that we have a couple of disks stacked over it. Like, alright, I'm going to be making another action for you, which is like this. From here, there'll be two of these arms like thingy coming out. I'm going to tell what these are in a minute. So, there you are. Like the number of disks they are, that many of them are present. So, here, yeah. Let's get labeling. Alright, so as you can see here, this is platter. I mean, like one disk is platter, and this is spindle. Like that, I think so. I said this is spindle. So each platter is divided into tracks, which is concentric, and each track is divided into sector, like you know how we cut pizza, like something like that. And then when you the pile of platters is cylinder. And then what good is storage without a read write? So we have RAM assembly, and attached to that is a read write head that actually reads data on each platter. And then the data is, we know what data is stored there. All right. And one important note, this when you zoom in does not touch. Let me show you how it looks close up. Suppose this is, the macro of this. So this is how it looks. There is an air gap, and this is magnet-based storage, which uses electromagnets to store data. So if it touches, then the disk would be scratched and would be ineffective to use. So now we know about the storage structure. Let's talk about disk scheduling and the algorithm. So we have platter divided into tracks, which has sectors, but they store data. And now are also given indices. The order which CPU decides to take all of these data and attend them just to save time and effort is called disk scheduling. Now let's talk about disk scheduling algorithms. There are six of them. Actually more than six, but let's discuss six here for simplicity. So we have like six of them. We have FCFS, SSTF, T-scan, scan, T-scan, look, and C-look. Let's get some examples to understand each of them. So the first algorithm is FCFS. Now the example here is, So here we have the value, which is start point at 33, capacity of 150, and we have some values 24, 108, 39, 11, 103, and 140. So let's make a number line. So now we have our number line and the start point at 33, capacity 150, and the following values 24, 108, 39, 11, 103, and 140. So now I'm going to be drawing some arrows. Now we're going to be starting from 33 and going to 24 like this. And then we need rough work column. Let me make it real quick. So here we have a rough work column. So I'm going to be calculating. So I have done for the first arrow. So I'm going to be doing for the rest. Let's sum these up and get the final value. It's 319. So the advantage here is that every program gets a fair chance and there is no indefinite postponement. But it may not give best time or best service. That's the disadvantage. That's why we're going to be moving on to SSTF. Right, so I'm going to be talking about. Okay, so let's do SSTF algorithm. So suppose we have this example right over here, and we have to get the answer. How would we do it? We have to draw a number line. Okay, so now our start point is right here, right? So now we have to get to the nearest point, which seems to be 39, because there's less distance between them. Now we need to store them. So we apply the same Honda, which is higher minus lower, and then take that result and add to all possible arrows. So now we're going to do it the same for everything, every arrow. So as you can see here, we have our calculation like this. So let's get the value. So now, as you can see right here, our total is 168. 168. The good thing about this algorithm is that it actually increases the throughput as well as reducing the overall time taken. But it's at the cost of treating some input output unfairly and prioritizing others, causing starvation. Using this example, let me explain the scan algorithm. In this algorithm, we actually start from the starting point, let's say 33, and then we have to reach the end while attending the service of the input request. And then we just turn around, hit another, and then serve, hit another end, and come back. So this goes on and on until everything is done. So let's do it in this example. So now here, what we can do is we can start off from the starting point, which is 33, and then at 10:39. At the same time, we record how much we have moved. So here we have moved 6. And now we keep going and then hit the end. So now we turn around and attend the rest of them. Okay, so now we better get the sum. So now let's add them all up. 231 plus 13 is 244. That's our total length covered. Scan algorithm is good because throughput is high and the variance is low in response time, and the response time is average. The demerit of this algorithm is that the request in the disk arm, which is already visited, has to wait before the algorithm can come back to it and attend those. Cscan is almost exactly identical to scan, but this time, instead of going bouncing off from end, it just like warps around. It goes to end and then comes out from the starting. Let me tell you through example. So we have this same example and starting point is 33. So now we start off like this. 33 to 39 first service. So we add up 6. 6. Right? Now we let us do it till the end. Now here we go all the way back. All the way back to 0 from 149. Let's do it. So now here we have to start again from left to right again. Now let's find the total. So we get 289. Here C-scan has an advantage of uniform wait time. Now we're going to talk about look algorithm, which is the algorithm which actually is like scan algorithm, but instead of going to the extreme end, it just goes to the last service and then bounces off. Let me tell you what I mean through this example. So let's start with, say, the starting point is 33 and we go to 39. So now we're going to be adding 6 as usual and going to the last, which is 140. So now instead of getting to 149, we just turn around. So there we have it. Let's get the total. 236. So now we're going to do CLOOK. So CLOOK in CLOOK algorithm, which is same as CScan algorithm, but not exactly. It actually like look actually goes from one end of service to another end of the service, not the disk. But this time it warps around instead of going end and then bounce off. Let's start off at 33 for this example, which is the same. And we go to 39 and we add 6 in the start. Let's keep going. So here we warp around and start from 11. Now let's get the total. So we get 250 here.